Today we're going to look at section 3.3, graphing systems of inequalities. Our objectives are to graph a system of linear inequalities and to write a system of inequalities from a graph. We will also be looking at some systems using our absolute values. So what do we need to consider? So now that we're graphing a system in a coordinate plane, again, we need to look if it's going to be a solid or dashed line or absolute value, if we're shading quote-unquote above or below, and now that we're graphing more than one line or absolute value on the same coordinate plane, which makes it a system, we need to actually look at where all the shadings overlap. That is going to be where the solution is, all the points that if substituted back into any of our individual equations will make the statement true. So how do we use a test point? Well, if you actually pick a test point, okay, you could do individual test points, but at the end, if you want to find out if your shaded area is correct, so let me give you a slight example. So let's say I have a line here, and I know I shade below. Okay, and then I graph, say, a different line, and I know I need to shade above. Our solution is where both shaded areas overlap. So if you want to think about a test point to see if you're true, pick any point in this area, substitute it back into all your different equations. If it makes each statement true, then you should have the right shaded area. So let's look at our first one. I have actually three linear inequalities that I want to put on the same coordinate plane. The first one is a horizontal line at y equals 6. So I'm going to go to y equals 6. It's going to be a solid line because it's a less than or equal to. Now, you could use a test point, 0, 0, or you could kind of think, I want all the y's that are less than or equal to 6. So in this case, I'm going to shade below. Now, instead of putting shading all over the place, I'm just going to kind of draw some arrows just so I don't have lines and shading all over my graph, because especially with the pen, it'll be too dark. So then we go to my next inequality. X is greater than negative 4. That's going to be a dashed line, which is vertical at negative 4. And I want to shade all the x's that are greater than that. Well, so far I know my solution has to be somewhere down here. And now I know I need to be on this part of the line. So if I look at this, I know my solution so far where the two shadings would overlap is just in this square or rectangle looking area. Okay, but I do have one more to put on here. Now I'm just going to use, I'll go back to the black pen for the last one. Now this is in slope-intercept form, so I'm going to go down to negative 1 for my y-intercept. I have a slope of up 3, right 1, up 3, right 1, and so on. Also down 3, left 1. This is going to be also a dashed line because it's greater than. Okay. Now I can use a test point because this actually does not go through 0, 0. So if I put in 0 and 0, I'm going to get 0 greater than negative 1, which is true. So that means I'm actually going to shade above. So I know originally my solution was in here, but now I have to shade above this line, this black line, which is this direction. So my final answer, if I go through and look here, sorry, let's get rid of that, would be in this area here. Let's do it with red then. Doesn't seem like the other colors. And this is your final answer. Now if you have shaded, if you actually shaded for the rest of it, you need to make sure that I know that this is your actual solution. And what the solution means is that if I pick any point in this shaded area, any ordered pair, if I substitute it into all three of these, it would make all three true. Let's try another one. 2x minus y is less than or equal to negative 1. Okay, that is not, well, that's actually in standard form, but I'm going to actually change it to slope-intercept form to make it easier. This is going to end up being y is greater than or equal to. Okay, if I subtract 2x and divide, I'm going to get a positive 2x plus 1. So the reason I switched the sign is because I ended up dividing by a negative, and you can take some time to come up with that. The second one, I'm going to leave in this form because I can get x and y intercepts pretty easily, and then the last one is an absolute value. So when I go to graph this, I'm going to go to up 1 for my y-intercept, up 2, right 1, and then down 2, left 1. Okay, this is going to be a solid line. Okay, and again, if you need to use the test point 0, 0, you can. 0, is that greater than or equal to 1? No, so I know I'm going to be shading this side, the side without the 0, 0. Again, if you need to do the work to show putting the test point in, go right ahead. The second one, I'm going to choose to do x and y intercepts. When I find my x-intercept, I substitute 0 in for y, which gives me x equals -8. Again, show the work if you need a little bit more, but this should be review. To find my y-intercept, I'm going to substitute a 0 in for x, which is going to give me a y value of a +4. So I'm going to go to -8, 0, and then 0, 4. Okay. This is going to be also dashed, but that's really far away. So if I notice I went up 4, right 8, which is the same thing. So if I go up 4, right 8, that's the same thing as up 1 over 2. So I'm just going to do that to make it a little bit more accurate. You can always reduce your slope. Okay, again, it's going to be dashed line. Always make sure you have arrows on your lines because it does go on forever. Now, if I put a test point of 0, 0 in, I'm going to get 0. Is that greater than -8? Yes, it is, which means I need to shade the side with 0, 0. So right now I know this part right here is my solution. But now I need to know I need to be above the red line but below the black line. So right now I know my solution is right in this little sliver here so far. Okay, and again, this would go on forever, but in this area right here. But I have one more to graph. So let me go back to red for this one. Okay, my absolute value. This is a downward facing absolute value. My vertex is at -2, 4. And my slope is a ±1/3 for each of the two sides of my absolute value of the rays. If you need help going back to this, you can go back to section, I believe it's 2.7. So we're going to go to -2, up 4. And then I'm going to go down 1, 2, 3. I'm sorry, down 1 over 3. Down 1 over 3. And as you can see why shading might be a little harder, you can do your arrows. I know they come out a little bit darker on here because of the pen, but you could draw it as light as you like. This is actually going to be a solid absolute value. And I need to, if I put a test point 0, 0, I'm going to get a true statement, which means I need to shade below the V. So let's think about this. I need to shade below the V, below the black line, and above the red line. So what area would that be? If I go to red, I need to be below the V, below the black line, and above the red line. So it's very similar. The only thing the V did, the absolute value did, to change my shaded areas, this tiny little sliver up here is no longer shaded like it was before. It was just the two lines. So again, what does this mean? If I pick any ordered pair in this shaded region, find the coordinate x comma y, if I substitute into each one, it will make all three a true statement. Let's look at the third one. Okay, this is an upward facing absolute value. It has a vertex of 3, -5, and a slope of ±2, or 2 over 1. So let's go to +3, -5, up 2 over 1. And then the same thing up 2, left 1. This is going to be a dashed absolute value. Okay. If I put the test point 0, 0 in here, I'm actually going to get a false statement, which means I'm not going to shade the side that has 0, 0. I'm going to shade the opposite side, which means inside the V. Okay. So I know right now my solution has to be in here. Nothing out here could be ultimately shaded at the end. The second one is in standard form, so I'm going to just do points. I'm going to find my x-intercept and my y-intercept, my 2 points. X-intercept is going to be 10, 0. Y-intercept is going to be 0, 10. So if I go to 10, 0 and 0, 10, this has a slope of 1. So I'm just going to go on the diagonal, and this is also going to be a dash. So I'm just going to put dashes on the diagonal between those. Okay. Now, if I put the test point 0, 0 in here, I'm going to get a true statement, which means I need to shade below this black line. So if I need to be above the V, but below the black line, so far I'm stuck in this area. Okay, my solution has to be in there. So let's see how much of that we're going to actually end up using. Let's look at my last part. I'm going to go back to red for this. Y is less than or equal to -8. So if I put the line -8 for y way down here, Okay, and I know I need to be less than this line. Okay, so y is less than -8. So now this is kind of weird. Where do all these shaded areas overlap? Below the black line, above the V, and below this line. It's impossible. This one would actually have no solution. There are no points, points that I can substitute in to make all three true because it is impossible for this to overlap. The black, if I shaded, would intersect with this, but all three do not. Let's look at D. Okay, D, we have 4 lines. They are all in standard form, so I'm going to do point slope. Or I'm sorry, point slope. I'm going to find the 2 points I need, x and y intercepts. So my x-intercept would be 4, 0. My y-intercept is 0, 4. Okay, I'm just going to do that for all of them right now, just to make it a little bit easier for the graphing. Okay, again, all x-intercepts should have a y value of 0, and all y-intercepts should have an x value of 0. That is it true again, no matter what equation you're looking at or what function you're dealing with. So that's 4, 0, 0, 4. This one's going to be -4, 0, 0, -4. It's a negative. This one's going to be -2, 0, 0, 2. And the last one's going to be 2, 0, and then 0, -2. So let's graph the first one at 4, 0, and 0, 4. Sorry, 0, 4 is up here. Okay, it's the slope of 1. So this is going to be solid. So on the diagonal of up 1 over 1, I'm going to draw a solid line. If I use a test point 0, 0, I'm going to get a true statement, so I know I need to be below this line. Let's do the next one in red. I'm going to go to 0, -4, 0, and 0, -4. Okay, so let's actually make this one black, just because it ends up being parallel. Makes it easy. And this is also going to be solid. It's going to go up 1 over 1. Okay, and I need, if I put the test point 0, 0, I'm going to get a true statement. So this is actually shaded, quote unquote, above the line. So right now my solution should be somewhere in here. That's where they overlap. Switch the red. I'm going to go to -2, 0, and 0, 2. Okay, again, this would have a slope of 1. This is going to be a dashed line. So on the diagonal of 1 up 1 over 1, I'm going to put a dashed line. Down 1, left 1. Okay, and I need to, if I put the test point 0, 0 in here, 0 minus 0 is 0 is 0 greater than -2. Yes, it's true statement, so I need to be below this line. But I already know so far my solution is in here. And if I need to be below the red line, now I know my solution is somewhere over here. That's where all the arrows are pointing. Let's try our last one. 2, 0, and 0, -2. Again, it should be parallel to that. It's also going to be a dashed line. So let's put a dashed line, up 1 over 1, down 1, left 1. Okay, and if I put the point 0, 0 in here, is 0 less than 2? It's a true statement, so now I got to shade towards 0, 0, which would be above this line. Okay, so if I think about it, it has to be between the black lines and between the red lines. The only area that is overlapped between all of them is this little space right here. So again, what does this mean? If I pick any point inside this shaded region and substitute into all 4 of my inequalities, it'll make all 4 true. So now that we've graphed them, how do we go backwards? Okay, we did one example of this back in the original shading one. So what I'm going to do is I have three lines, 3 linear. Okay, to show they're all together, I'm going to do some sort of bracket. I'm going to get to 1 in a second. So 1, I see I have, I'm going to just do slope-intercept form because my y-intercept is 0 and my slope is up 1, right 1. Okay, so my b is 0 and my slope is up 1 over 1. So I know it's y, and I have 1x plus 0. Now, usually, we don't actually write all this, okay? We would just write x, okay? So what we could do, it's the same thing as y and x. Now, do we shade above this line for greater than or below the line? And that's kind of an easy way to look at it. So since I shaded below this line, it's going to be less than, and it's a solid line, so I'm going to put less than or equal to. Number 2, okay, is a horizontal line, so it's a y, and we're at -3. Because it's dashed, I know I'm not going to have the equal sign, but I shaded above it, so it's going to be greater than. My third one is vertical, so it's going to be an x. We're at 6, Again, it's dashed, so I know I'm not going to have the equal to sign, and I shaded. Now for vertical lines, we have left and right. Left is our less than numbers, right is our greater numbers, so we're going to be less than. Okay, so this would be the best way to write it. You could have this, but technically we usually don't write our standard form like this. You might write this to help you out. You could put a 1x, but we usually don't write plus 0 because it's not needed. Let's try again. Now I have a line and an absolute value. So if we look at the line, okay, let's do this one first. All right, I have a y-intercept of 10, so my b equals 10, and then let's look at the slope. So if I look, I picked 2 points and went up 3, right 1. So up 3, right 1, so I'm going to have y. I'm going to have 3x plus 10. Now, did I shade above the line or below the line? So how I determine that is I put my pen anywhere on the line, and I just think, do I have to move my arm up or down to shade? Since I have to move it down, it's going to be less than, and it's a solid line, so I'm going to put the equal to symbol. My second part is a absolute value, or v. So I'm going to do this one second. My vertex, okay, my vertex is at 0, -7. I know this faces up. And let's look at the slope. Up 1, right 1, up 1, right 1. So it's plus or minus 1 because this is up 1, left 1. So how do I write this? Remember, we have our y. Take your slope and use that as your a value, which is a 1. I'm going to do x minus 0, which is just x, and then minus 7. I don't need an equal to symbol because it's dashed, and I shaded above. So again, put your pen on anywhere on the absolute value, and I moved my arm up to get to the shading. So I'm going to be greater than. And that would be your system. You don't need to have this 1, but if you write it, it's okay. And let's look at one more. So I have 2 absolute value and 1 line. And again, it doesn't matter the order you put it in here. I just do whatever one I think is going to be easiest for me first. So let's do this. This is a horizontal line, so it's going to be y, and it's at -5. It's dashed, so I know it's going to be greater than or less than, and because we shaded above, it's going to be greater than. Let's do this one second. I know this one faces down. I have a vertex at -6, 4, and a slope, again, is plus or minus. Okay, pick 2 points. Down 3, right 1. Okay, so but we don't have to worry about this plus or minus because it's already in there. The down is taken care of here. So I know that I'm going to do y. I'm going to use this as my a, but since it faces down, I know it has to be a -3. Absolute value of x plus 6, and then plus 4. It's dashed, and we shaded above the v, so it's going to be a greater than symbol. And then let's look at our last one. This one, I'm just going to do the work over here, faces up, has a vertex of +2, +6, and a slope of up 1 over 2. Okay, so I'm going to have my y. My slope, and because it faces up, is going to be, I'm just going to put the 1/2 on the outside, x minus 2, and then a plus 6. If I go anywhere, I had to shade below this, and it's solid, so I know it's going to have the equal to symbol. And this would be my system. And you can always do a test point. Pick a point anywhere in the shaded region. Substitute in all 3. It should make all 3 true. If it doesn't, then you might have to reevaluate your inequalities.